So, hi everybody, today we are going to talk about morph names. You will see in this part of the screen what I'm going to say if it's necessary. So, why are we going to talk about morph names? Because we want to be able to identify morphs. And we will see in a minute what I mean. Let's create two rectangle morph. Create the rectangle and open it in my hand. This is, let's call it rectangle 1. It's called like that in the workspace. And let's open another rectangle. Rectangle morph new. Okay, rectangle is created. Open in the hand, so on the cursor. To distinguish them, let's make the rectangle 2 a bit bigger. So central click, and here it is, a bit bigger. Very well. So now you would say we are able to recognize these two rectangles because one has variable R1 and one has variable R2. Okay, in first approximation, this seems enough. But to have an idea of how complex the thing can become, let's see how many rectangles there are already in the system and if it is so easy to identify them. Allora, rectangle morph, all instances. I want to see all instances of rectangle morph. I do Ctrl-Shift-I to explore the result. And you see here, in the system, there are quite a bit of rectangles already, like 95, 94. What? There are many. So how do I identify my two rectangles here? Well, since it gives me a preview, I could try to scroll down and go by color. For example, you see, they could be 81, 82. Let's see if there are others. 94, 95. It could be. Any of these could be. So let's see first a little bit of a trick I show you. If you do flashBounds over aMorph, you see it does like that. Let's do it also for R2, so you convince yourself it's general. You see, this is what flashBounds does. So let's try to flashbound some of these things, okay? For example, let's try to flashbound 80. So to flashbound 80, I can do or like this, self flashbound. But it's something there. There's nothing to do with us. Let's try to this. Flashbounds, nothing. Let's try with this one. Haha, I found rectangle 1. And haha, I found rectangle 2. Very well. Let's become a little bit more technical now. You see that the system gives calls a rectangle morph with this first part that is recognizably the class name and this second part. The second part is called the identityHash. Let's see them. So for the morph that equals 95, that now it's highlighted, and so it will be the self. Self means this kind of this object that I have highlighted here. And self, I say class, tell me the class of this object. It tells me it's a rectangle morph. In fact, it's a rectangle morph. Delf, I tell him self, tell me the identity hash. And you see these numbers correspond to these numbers. Also, you can do self. I can do Ctrl-P for print it. You see, it gives me exactly the same representation that is here. Now I highlight and shift double quote to comment. And I can do also like this. Self print string. It's another interesting method. I mistook here. Self print string. it gives you, you see, the string representation of this. This can be also useful. Okay. So the same thing we said, so that an object has a class name and identity hash. You can see them also from here. So R1 class, here it is, R1 identity hash, of course, and R1, you can do Control P, and usually you would do like this, Control P. Or you can do R1 print string again. Very well. If you look it into the world point of view, let's say the morphic, more user interface point of view, you can get the same information from here. If you center click, it tells you, in this case, this vague rectangle thing. Let's do center click also here, rectangle. Rectangle, you see, it tells us nothing. Però, if you do center click and branch, then explore morph, okay, it gives you the print string here, so class name and the identity hash here. So with that, you are able to recognize the morphs and know that this rectangle morph, you see, is the same than this. And if you open another branch here, explore morph, you see that this rectangle morph 2 is this, what he calls instance 95 of all rectangles morph. Very well. Now let's close this for the moment because we want to do a little bit of an experiment. Let's say we want to identify our morph in another name, so in another way. So we change the color. We gave this purple color to the morph, and then again we go to see all classes of RectangleMorph. So RectangleMorph, all instances, dot, and then explore. You can do also like this, explore, and then Control D for do it. It's exactly the same equivalent of before. In this case, we should be able to recognize this rectangle immediately from the color. Let's go to try it. Here it is, RectangleMorph, here it is. And let's be sure it tells us that the identity hash is this. Let's go here, explore morph. Here is the identity hash. Perfect. So we are sure that this rectangle is this rectangle. Very well. Let's go a step further and let's give morph name we like more than that to recognize. For example, this we want to call it my rectangle 1 and this is my rectangle 2. So the first way is that we have already a reference to this guy here that is R1. The way to do it, click is this, R1 name, and then let's call it my rectangle 1. Control D for do it. Now let's look what happened. R1, Control P, print it. Look, now we have the class name, the name we've just given, and the identity hash. Let's check it out part by part. So R1 class, RectangleMorph. R1, this is called knownName. You see, my rectangle 1, and R1 identity hash. Perfect. Let's go to see it in clicking in the user interface. So center click. You see now that the knownName, the one we have given now, appears here immediately, and it's easier to recognize this morph. There is another way to give a name of the morph from the user interface. Maybe there is a better way, but I found this one. So if you collapse the morph with this hello, and then you go here, blue arrow, change name, my rectangle 2. Accept. You see what happened. in the collapsed morph, the title of the collapsed morph is the knownName. Now I center click again, knownName here, center click, knownName here, very well. So now let's do R2, Control P, my RectangleMorph 2. Let's go again to see all the instances of rectangle and see if we can easily identify them now. So we can go scrolling as we did before. Let's go to scroll. We find something. Aha, here they are, my rectangle 1 and my rectangle 2. Okay. So let's see other things I want to show you. Some extra stuff. So for example, flaps. Add the morph via flaps. What happened to this knownName? Let's go to see it. When you add a morph via flaps, let's try rectangle. Let's see. Well, there's still the knownName rectangle, but let's insist. Rectangle up, rectangle 1, rectangle 2. So you see, if you add the RectangleMorph or any other morph via flaps, the known morph is set. Instead, if you did it by the workspace as before, it's not set by default. Let's go to see another interesting thing. Where is the knownName stored? So let's go to explore this morph, for example, my rectangle 1. Go to explore it, explore morph. Let's go to see inside it. You go to extension and external name. So here it is stored in the extension part, which is related to the player part of Squeak, which we will not talk about today, okay? But consider it is in a special position. And that's why, probably, I guess, it's not set up when you define the morph via workspace. And it is when the morph is defined via flaps. Anyway, this is a consideration about player we will see in the future, maybe. Another thing, suppose we want to be able to reference this morph in this workspace, okay? Let's change it color, I don't know, to red, or orange, just to be able to call it. So this orange morph, we want to do something with him inside the morph, inside the workspace, excuse me. So how do we do it? So there is this nice trick that is this. Create text or reference in the workspace, and then you drag and drop the morph in the workspace, and you see it call it rectangle. Let's see, it's really him. This rectangle variable, let's see, class, it's RectangleMorph. IdentyHash is this. Let's check here the IdentyHash of this thing. It's him. You see, we checked, it's him. So we can do something with it now. Let's say change color. Change color to yellow. Very well. And this is a very nice feature of the workspace. Let's try to drag inside something else just to understand something interesting. If I drag here this, the variable it creates called rectangle1. If I drag this, the variable name is rectangle2. If I drag this, my rectangle2, so you understood what I want to show you. The name it creates in the workspace is the name in the part knownName. Okay? Excellent. Last thing about this subject is that these variable name, where are they stored? You go here in the workspace blue arrow, inspect variables, and you can see These are this variable R1, R2, rectangle R1, R2. If you delete the workspace, goodbyes to the variable names, okay? But you can still use the name myRectangle1, myRectangle2, because these are inside the morph. And we can do it. Let's do it. Let's close the workspace, open another workspace. Now you see there is no R1. R1 is nothing, undefined object. There is no R1. Let's go to see the variables inside here. It's only R1, that's undefined object, it's nothing. So in this situation, again, or you drag in the morph and you get a reference to it, or we can do it as before, RectangleMorph, all instances, and then we go select, and select, for example, for each morph of this kind, we say that we want morph such that the printString includes substring. Let me see if, say, it should be okay. Includes substring my, for example. I mistook something here. That's it. Let's see all the RectangleMorph having my in the print name. Here you see my rectangle1 and my rectangle2. Perfect. So I want to reference my rectangle1. Let's go to see it. I mistook something. Perfect. So first, shift brace first, and here it is the object, and let's change color to my rectangle1. Was a color black. Black, maybe not white. And so this is our last example of referencing the morph. At the same thing, you could reference it by the identity hash, for example. So for today, this was a long video, but I think it's a very interesting subject. Goodbye.